What if I told you that the secret to feeding billions of people is hidden in plain sight, right here, in these serene rice paddies? But this ancient art of rice farming holds a dark secret, a hidden challenge that consumes 80% of Asia's fresh water and releases more methane than the entire aviation industry. We've always believed that more water means more rice. But what if that's a dangerous myth? How can we grow more, with less? The answer lies not in more water, but in more data. Welcome to the Fields of Innovation YouTube channel. Smart farming starts here. Discover the future of agriculture, where we share information about technology applied in agriculture. Today, we're diving deep into one of the biggest revolutions in farming, how AI is creating smarter rice field drainage systems. For centuries, rice farming has followed a simple rule: flood the fields. This method, known as continuous flooding, serves a dual purpose. It provides the rice plants with the immense amount of water they need to thrive, and simultaneously suppresses weed growth, acting as a natural herbicide. But this age-old practice comes with a steep price. Overwatering is rampant, leading to colossal water waste in a world where fresh water is becoming increasingly scarce. More alarmingly, these waterlogged fields become breeding grounds for anaerobic microbes that produce methane, a greenhouse gas over 25 times more potent than carbon dioxide. The delicate balance between growth and waste has always been a tightrope walk for farmers in major rice-producing nations like Japan, India, and Vietnam. The critical question has always been, how can we find that perfect water balance? How can we give the crop exactly what it needs, precisely when it needs it, without drowning our planet in the process? This is where artificial intelligence enters the field, promising to solve a puzzle that has stumped farmers for millennia. To truly appreciate the AI revolution, we first need to understand the mechanics of traditional rice field drainage. A typical paddy is designed with a series of inlets to bring water in and outlets, or gates, to let it out. For generations, farmers have managed this process manually, relying on experience, intuition, and visual cues. They walk their fields, checking water levels by eye and opening or closing gates based on a schedule passed down through generations. However, this manual system is fraught with inefficiencies. Fields are often uneven, causing water to pool in some areas, while others remain too dry. Timing is everything. Draining too early can stress the plants, while draining too late leads to waterlogging, which suffocates the roots by cutting off oxygen supply. To combat these issues, a more sustainable technique called alternate wetting and drying, or AWD, was introduced. AWD involves cyclically flooding the field and then allowing the water to drain and the soil to dry out to a specific level before re-flooding. This method is proven to save water and cut methane emissions significantly. The problem: manually implementing a WD is incredibly labor-intensive and requires constant monitoring, making it difficult for farmers to adopt at scale. It's a brilliant concept held back by human limitations. This is where the magic of AI comes in, transforming water management from a guessing game into a data-driven science. The system begins with a network of Internet of Things, or IoT sensors strategically placed throughout the rice paddy. These small but powerful devices work around the clock, collecting a constant stream of real-time data: soil moisture levels, water depth, ambient temperature, humidity, and even the chemical composition of the water. This raw data is then transmitted to a central AI platform. Inside this digital brain, sophisticated algorithms get to work. These aren't just simple programs. We're talking about advanced models like neural networks, which learn from historical data to recognize patterns, and fuzzy logic, which can make decisions based on imprecise information, much like a human expert would. The AI analyzes all the incoming data, compares it to optimal growth models for that specific rice variety, and predicts the exact moment the field needs to be drained or irrigated. Once the AI makes a decision, it sends a command to smart actuators connected to the fields, gates, and pumps. These automated devices then open or close the water channels with surgical precision, executing the optimal irrigation schedule without any human intervention. It's a seamless, self-regulating ecosystem where data is turned directly into action. But how does this digital intelligence connect with the physical world of a farm? Integrating AI with existing field infrastructure is the crucial step that brings this technology to life. The entire system is orchestrated by a centralized AI platform, often accessible to the farmer via a smartphone app or a dashboard on a computer. This platform acts as the command center, creating a connected network between the sensors collecting data and the pumps and gates that control the water flow. To make the system even smarter, advanced technologies like drones and satellites are brought into the mix. Drones equipped with high-resolution, multispectral cameras fly over the fields, creating detailed topographical maps. These maps reveal subtle variations in elevation across the paddy, allowing the AI to plan a hyper-efficient drainage strategy that ensures every square meter of the field receives the perfect amount of water. Satellites provide a macro view, monitoring crop health, water stress, and weather patterns over vast areas. This integration of ground-level sensors and aerial imaging gives the AI unparalleled situational awareness. A powerful case study comes from Japan, where agtech pioneers have implemented this integrated system. The results are staggering. Farmers reported a 30% reduction in water usage and a significant decrease in labor costs, all while maintaining or even improving their crop yields. The tangible outcomes of adopting AI-driven drainage systems are transformative, offering a win-win scenario for both the farmer and the planet. The most immediate and significant benefit is water efficiency, by delivering water only when and where it's needed. These systems can slash water consumption by an incredible 30 to 40%. This not only conserves a precious resource but also dramatically lowers pumping costs for the farmer. Secondly, it leads to yield, stability, and even improvement, by preventing waterlogging and ensuring the roots have access to oxygen. The alternate wetting and drying technique facilitated by AI creates healthier, more resilient crops. This translates directly to more stable and often higher yields. Beyond the farm gate, the environmental benefits are profound. The AWD method has been proven to reduce methane emissions from rice paddies by up to 48%, making AI-driven drainage a powerful tool in the fight against climate change. Finally, the economic advantages are undeniable. With automated systems handling the irrigation schedule, the need for constant manual monitoring is eliminated, freeing up the farmer's time and reducing labor costs. Less water also means less electricity used for pumping, further trimming operational expenses. This isn't just a futuristic theory. AI-powered water management is already delivering real-world results across the globe. In Japan, the company's Sora technology is at the forefront, integrating sophisticated AI with drone technology. Their system not only automates irrigation, but also uses drone imagery to detect early signs of disease and pest infestation, providing a holistic smart farming solution. Moving to the United Kingdom, Mantle Labs is leveraging the power of satellite data. Their platform analyzes satellite data to provide farmers with insights on soil, moisture, and crop health, enabling them to optimize irrigation schedules across massive landholdings without needing extensive on-ground sensor networks. Perhaps one of the most impactful examples comes from Vietnam, a nation where rice is a cornerstone of the economy and culture. In several pilot projects, smallholder farmers were equipped with basic IoT sensors and an AI-powered mobile app. The results were astounding. These farmers achieved a 12% increase in their rice yields while simultaneously reducing water and fertilizer use, proving that this technology can be scaled to empower even the smallest farms. These case studies demonstrate that AI is not just a concept but a proven, adaptable solution that works in diverse agricultural and economic environments. So, how can a farmer begin this journey into smart agriculture? The implementation roadmap can be broken down into a few key steps. It starts with a site assessment. A farmer, often with the help of an ag-tech specialist, needs to evaluate the field's topography and existing infrastructure. The first practical step is the installation of IoT sensors. These need to be placed strategically to capture representative data from across the paddy. Next comes selecting the right AI platform. This could be a comprehensive software suite from a major ag-tech company or a more accessible APB solution from a startup. The key is to choose a platform that is user-friendly and provides actionable insights. Once the system is in place, a crucial phase begins. Training the model needs to be fed with local data about the specific soil type, rice variety, and regional climate to fine-tune its algorithms for optimal performance. The cost and scalability of these systems can vary greatly. A small-scale farm might start with a few sensors and a mobile app, while a large agricultural enterprise might invest in a full-scale deployment with drones and satellite integration. To make this transition easier, many governments and agricultural organizations are offering grants and subsidies, and partnerships with local ag-tech startups can provide the necessary technical expertise and support. Of course, the path to widespread adoption is not without its obstacles. One of the biggest challenges is connectivity. Many rural farming communities lack the reliable internet access required to run cloud-based AI systems, a hurdle that needs to be addressed through infrastructural development. Another significant issue is the need for localized AI training. An AI model trained on data from Japanese rice paddies may not perform optimally in the unique conditions of India or Vietnam. Each model must be calibrated with local data to be truly effective. But looking ahead, the future of this technology is incredibly exciting. We are moving towards fully autonomous drainage systems that can predict weather changes and adjust irrigation plans preemptively. Imagine a network of smart farms that share data with each other, creating a collective AI that learns and adapts at a regional level to combat climate change and optimize resource use. The ultimate vision is a self-regulating rice ecosystem, where AI, robotics, and biology work in perfect harmony to produce more food with minimal environmental impact. In conclusion, AI is poised to fundamentally rewrite the rules of rice farming. It's transforming an ancient practice from one of guesswork and waste into a precise, efficient, and sustainable science. By harnessing the power of data, we can unlock the secret to growing more rice to feed our expanding global population, all while conserving our planet's most precious resources. We are not just talking about technology. We are talking about creating a future with more food, less waste, and a healthier planet for generations to come. This isn't science fiction, it's the next chapter in agriculture, and it's happening right now. Now we want to hear from you. How do you think AI could change farming in your country? Let us know your thoughts in the comments below. And if you found this video insightful, don't forget to like, share, and subscribe to Fields of Innovation for more on the future of agriculture. Thanks for watching.